and we started talking about, very high level understanding of the concept that what is an architecture and, how it, oh, I forgot to start my recording, or is the recording is on now? Yes, okay, perfect. So, we started talking about very high level architectural concept without really going into details about technical definitions and what really an architecture consists of. Uh, but we had a high level discussion and some try to understand architecture with the help of civil engineering examples and so on and so forth. Now, today we will inshallah be defining more formally what a software architecture is. And we'll look at these different elements, different concepts which help us understand architecture. And from next week, inshallah, we'll talk about styles as well, and we'll look into these, basic styles and what really they look like, how they are structured, what are the different constraints in it. So let's dig into our first aspect, which is software architecture more formally. So one of the definitions, and there are so many definitions out there, the one definition, and I think we talked about this concept on Tuesday as well, is that a software architecture or software systems architecture is what? Is a set of principal design decisions about the system. All right. Remember that one, right? Anybody recalls what we talked about? What are the principal design decisions? Anybody remembers what we talked about this, right? We talked about that there is something called
Yeah,
principal design decisions.
yeah.
Go ahead, please.
We talked about that there is a principal design decision and non-principal design decision.
Exactly. So there are certain decisions which are, all of them are design decisions, right? Uh,
Yes.
but some of them which impacts your architecture are classified as principal design decisions. So any design decision which gonna directly impact your architecture is called principal design decisions. And of course, you will have set of them. So it's not one. You can have set of them. Now, this word principle actually does what? It implies that, an importance that grants, or in other words, the word in principle is there because it's just to distinguish that, from a set of design decisions you have taken in your application, ranging from, selection of structure of your system to classes to inheritance, association, all of them are design decisions, but some of them have an impact on the architectural status of the system. And hence, those decisions, a subset of them, these design decisions will be classified as principal design decisions. This, of course, we all understand this, I think, and we had a good discussion on this on Tuesday as well. It implies that not all design decisions are architectural in nature. And there are only few based because of those few decisions, your architecture can be changed. Now, this is that they did not necessarily, in other words, these not all of these design decisions impact the structure of your system. For example, selection of a certain algorithms or data structures will not impact a system's architecture. All right. Hence, these decisions, the selection of algorithms and data structures, yes, they are design decisions. So it's part of these decisions. But since they do not impact the structure of the application, the way you're going to have, a client server, for example, or an event based, they don't really impact. Hence, they will be classified as design decisions, not as principal design decisions. So far, so good, guys.
Yes.
Okay, so everybody is comfortable with this concept now, the principal design decision, right? So any decision which is going to impact the architecture of the system, the structure of your system, the layout of your system will be will be classified as principal design decisions. All others are just design decisions.
Yesterday, doctor, you talked about like the color is not principle or something like that. Like the last
Mm.
2 minutes.
Mm-hmm. Can you refresh my mind, Khalid? The colors.
the colors and
Oh yeah,
like
the user interface.
yes,
Yes, yes,
yes, yes.
yes, 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 yes. So for example, you know, if I have a structure of an application, so let's say I'm making a mobile application, right? So I have this client, which is on the mobile device, right?
Yes.
And then I have some sort of a business logic server, right? And maybe I even have a database server. Now, uh, any decisions which you are taking, for example, on how these classes within it are structured, right? And you say, oh, between class A and B there will be inheritance, or you can go on and change, no, we made a mistake, maybe we should not be having inheritance, we should be having abstract class or interface or something like this. They are design decisions, but they are not changing the structure of the system, correct?
Yes,
The
they are not.
structure will still, yeah, so structure will still the same. Hence, they will not be classified as design decision. No, a decision such as, for example, I have a database server and you decide to change. No, I'm not going to have a database server on it on my own. I'm going to put everything on cloud,
Yeah,
right?
this is the change everything.
Yeah, it will change everything. Hence, this decision is your principal design decision.
Okay. So
Okay.
the same concept. So that example was in this concept.
Exactly. That example was for this concept.
Okay.
Right. So at that day on Tuesday, I didn't give you any definition, but today I'm giving a definition and basically the reason we talked about that because actually, some of us, there are many definitions of architecture. One of these definitions classifies that, the decisions which impact the structure of the system are called principal design decisions, and an architecture is a collection of principal designs. Now, moving forward, an important point is here. Have a read of this one. So what do you guys make of this statement? I'm saying how one defines principle will depend on the stakeholders, what the stakeholders define as a system goal. Now, what I mean by this is, like, for example, this example I shared with you guys that instead of having a database, physically having our own database server, we moved everything to cloud. Well, in most of the systems, this will be principal design decision because you're really changing the structure of the application, right? So there are certain examples of principal design decisions which always be principal design decisions because they always going to change the structure of the application. But there can be cases where, for example, a selection of a certain algorithm, right, doesn't make any difference into the structural change. Hence, it will not be principal. While in some other system, that selection of an algorithm can make a difference in the structure of your system. Right. So this word principle is very context specific. It's very much depends on your requirements of the system. Right. So of course there are certain clear cases, as I just said a few minutes ago, there are certain clear cases where moving away from a physical database to a cloud-based database, storage is clearly a principal design decision because you're changing the structure. While selection of the algorithm in journal will be not principal design decisions because they really rarely change the structure of your system. But there can be cases where depending on your requirements, selection of an algorithm now becomes a principal design decision because it's now changing the structure of your system. Are you able to grab this concept with me?
Yes, Doctor, can we see security as a principal?
Design
Uh,
decision.
yes.
Hmm. I will say this way. I will say that the selection of the protocol maybe, right, or the or the different devices like intrusion detection systems, or all of this will and potentially will contribute to structural changes in your system. Hence, you can those you can classify them as your principal design decisions. Yes, security related decisions definitely have impact. And actually, it's a good, excellent example. Actually, I was struggling with example today somehow in the first section, and I will share with them as well, inshallah. It actually gives me an idea why somehow I was struggling. So this is actually, see, for example, if you select an intrusion detection system, right? That selection of an intrusion detection system, uh, if you place it here, does it change the structure of the system?
Yes.
I think yes.
Yes, it does. It does, because see, originally you were communicating this way. Now you are actually going through certain intrusion detection system, right? So this decision, this is a security-related decision. It actually impacts your what you call, the structure of the system. While, for example, you're using encryption keys or using different encryption algorithms, right? Those encryption algorithms, algorithm number A versus B versus C, doesn't really impact the structure of the system. Both are security related decisions, but in one case, this is impacting the structure, hence it's principal, otherwise it's not principal. Okay. Now, this is one definition. It's not a bad definition to understand architecture from these perspectives, but I have a better one, and the one actually I like, and the one, inshallah, we'll be following for the architectural discussion in this semester. Or even matter of fact, to be honest, when I teach 416, I use that definition again. So this definition is by Mary Shaw and Garland, and they define architecture more crisply. And they say that architecture is a design level decision naturally, and it does what? It involves description of the elements from which the systems are built. This is number one. So they have elements, which are actually, the description of the subsystems and so on and so forth. This is one thing. Now these elements, number one, they interact with each other as well. So they share data, they share information. And number three is we have certain patterns that guide the composition of these elements and and interactions. And number four is that because of these patterns, you will have certain constraints. Okay. What comes to your mind when you look at this definition? Are you able to visualize this now? This is a more crisp and thorough definition, isn't it, as compared to the concept of principal design decisions, right?
Yes.
So, an architecture is actually a description of the elements from which the systems are built. Technically, we call them components. Okay, so in other words, what I'm telling you now, that an architecture of a system consists of components. These components interact with each other, so they have some interactions, and as a result, we have something which we call them connectors. And then these components and these connectors are organized not randomly, but we can use certain styles to organize them. And because of these styles, you have certain constraints. So for example, again, going back to our mobile example, a piece of software running on your client will be at least one component, okay? So this is your component. Business logic, maybe one component. It could be easily multiple components. Database storage component. Your architecture is what? It's a collection of these components. They interact with each other. using the concept of connectors. And then we organize them in a certain style. For example, in this case, this is a client server style, right? And because of the client server style, there is a certain constraint. And for example, what is a typical constraint in a client server architecture? Because you guys are very comfortable and familiar with client server architecture.
The client must be connected to the internet, for example.
Yeah, or it should be connected to the server, right?
Right.
Yeah. Any other constraint? Client server architecture style puts.
Maybe the type of the server
Type of the
and
server.
and the capacity of the server.
A client server as a style is very generic, so it's really doesn't it doesn't do that. Anything else? Think about any other constraint, a very basic constraint it puts.
There's only one server.
You can have multiple servers as well, to be honest.
Maybe you cannot access the data directly, the database.
What if I have a mobile application, which is a very typical example nowadays, where the server basically just contains the database. I just query the database and get the data and just display it. Think about it. There is a very fundamental constraint. One constraint you guys identified, that client talks to server. It actually puts another constraint, a very fundamental constraint.
The server responds to the client.
The server responds to the client, true. Can client talk to another client?
Maybe through the server, like WhatsApp.
Yeah, through the server is a different thing. Can a client directly talk to a client?
No.
No.
Like peer-to-peer?
Yeah, that's a different style. Good point. That's a different style. If you as an architect has taken a decision that I have components, and these components are connecting through certain connectors, and the style I have decided is a client server style, the constraint is what? Constraint is that a client will talk to server. Clients cannot talk to another client. This is not allowed. Right? Is this point clear? Now, if you make this connection allowed, then it is a style. It is an architecture. There's no doubt about it. But is it a client-server architecture?
No, it's a client-client architecture.
Yeah, it's something else. Yeah, it's completely different. Yeah. Right? Am I able to explain this point to all of us? Some show of hands will give me some confidence.
Yes.
Okay. Thank you very much. Thank you very much. Okay. Now, okay. So let's now look at this again one more time, the definition, because this is our fundamental building block. So a system consists of components. They are connected or structured using certain connectors. The layout of these connections and components depends on styles. And depending on which style you select, you will have constraints. Like if you select a client server, it has its own constraints that all clients needs to talk to the server. The clients cannot talk to clients. While if you select a peer-to-peer architectural style, peers can talk to other peers. And a very pure P2P system, there is no server, so on and so forth. Right? I'll talk about different styles, inshallah, as we move along next week, inshallah. But today we need to just understand the definition. I'm going to formally define what a component is and what a connector is as well. But before I do that, what comes to your mind? What is a component?
It's a part of a system.
Yes, a part of a system. Yes, go ahead, please.
It's a piece of code that have a functionality to do, and it is done before the system, so it's already
Yeah, it's like so maybe is self-contained. It's self-contained. It's like a functionality or collection of a functionality of a systems is self-contained. It can, you know. So can I say, I have a question then. Can I say a class is a component?
Yes, of course.
Yes.
In general, yes.
I think in the class diagram, you can say a class is a component of the class diagram. But maybe in
overall
the
bigger
software
picture.
architecture, yes,
Yes,
maybe in
yes,
software
go on.
architecture, the component is more than a class. Maybe it's like a big part, including many features that are related to each other.
Absolutely, you're correct, Abdullah. You're absolutely correct. It's more like packages, more like collection of packages. All right. So a component and architectural level is typically one class is typically not a component in an architecture level. It has to be a collection of functionalities, a subsystem, a package, or in more realistic words, a collection of packages, which gives you a certain functionality. Okay. So this is very important for us to understand that cardinality of a component is that it's not it's very rarely, unless the system is such a small system. Classes are not components. Yes, collection of classes to get put together as packages, and then those packages put together will make components. Okay. We will be formally defining component and connectors shortly as well. So let's move on. Now, but before I talk about component and what is really a component definition and connector definition, I also want us to understand one more concept, which is the temporal aspect of architectures. What's the meaning of the word temporal? Something which changes over a period of time, right? Okay, so some things which changes, which is, you know, not constant. So what we are saying here is that architecture has temporal aspect is basically, see, we all know this because, you know, we are whatever the process model we are following, the design decisions we are taken are actually not something which is written on in a stone in a sense, right? So we take a design decision, then as our understanding improves, as the system evolves, those design decisions are made and unmade over a system's life cycle. True?
Can you give us an example?
Okay. Yes. Let's say you have design decisions like, for example, you know, let me start with the very basics. The class diagram. In a class diagram, you might decide that I'm going to have an interface between three classes. Oh, sorry, an inheritance between three classes, right? So I'm going to have a parent class and two children's. Later on, as your understanding improves, you say, nah, I don't think so. I don't need this. Maybe I just need, you know, an interface here, right? So your decisions change, right? As your system evolves, as you understand the system better, right? So is true for architectural decisions as well. Your architectural decisions also change over a period of time as your understanding of the system improves. You may start with an understanding that this system is going to be a client server architectural style, but as you understand the system, you realize, no, I don't think so. Probably a better solution will be, say, for example, peer-to-peer, right? So your decisions, design decisions, like anything in your software application development lifecycle, they are, unless you're, you know, using even if you're using waterfall model, still you change things. So design decisions change, and so is true for architecture. Your architectural decisions are also temporal in aspect that, you know, over a period of time, they evolve, they change. Of course, they are not like, you know, a piece of code being written for a method, so hence which can frequently change. They change, but after some time they stabilize as well, right? But they do change. And at a given time in the system life cycle or the life of the system, you will have only one architecture. This means at a given time T1, I will only have one architecture. I like your special attention for this because this is a key point to understand. That if, for example, you're developing an application and you are, for example, in the first week of development of your system, you decide a certain structure for your system. After 1 month, after 2 months, as you have understood better requirements, you have come up with a better understanding of your system requirements, and you realize, maybe we need to make a change here. All right. But at a given time, at any given time, how many architectures you will have?
One.
Only one architecture. Now, can that architecture change?
Yes.
They can change. Yes. But for a given time, for whatever time it is, there will be only one. So if time T1, I have an architecture, at a time Tn, I may have a completely different architecture or a changed architecture. Okay. But at this time, I will have only one. Even at a later stage, I will only have one. This could be exactly the same. The architecture could be exactly the same, or they could have some changes in it. So far, so good?
Yes.
So, and this is the meaning of the temporal aspect of architecture. Of course, we know that architectures will change over time, especially in the beginning of the software development lifecycle, especially at the requirements design phase, early phases. It will be a bit volatile and it will change frequently. Of course, as you move towards more like source code writing and testing and all of that part of life cycle, probably they will be stable and they will not be changing a lot then. Okay. Now, for us to understand this temporal concept, we also have to now understand from an architectural language perspective. Usually we distinguish between different architectures at different stages of the life cycle with two keywords. One is called the prescriptive architecture style, and the other one is called the descriptive architecture style. Take a moment to read what is the meaning of a prescriptive architecture. So what do you guys think? What is a prescriptive architecture?
Maybe it is like I am listening to a client, what he wants, the requirement, and I am imagining how I am gonna implement it, or how I am going to architect it.
That's true. That's true. So it could be like at that very early stage, right?
Yeah, very early.
But it doesn't. But it can be even, for example, when you design your system. So in other words, what you say is that an architecture, prescriptive architecture, captures your design decisions made when prior to the system construction. So if you are, for example, in your case, for example, if you're developing a using your agile approach, then probably at that stage is something you have a visualization or maybe some very high level documentation. And if you're using iterative, probably it could be well documented architecture structure. But an architectural structure, architecture design, which has been developed before the system has been constructed, it's called prescriptive architecture. Okay, as we say here, as conceived, as intended. So if this is prescriptive architecture, then what is descriptive architecture then?
It is how the system is actually built.
Exactly. So this is exactly the way the system has now been developed. That architecture is called descriptive architecture as implemented. Now, for a system, once a system has been developed, how many architectures I have?
One.
Just one.
Just one. Jazakumullah khair. Absolutely. As we said in the previous one, just one. At a given time, only will have one. So once the system has been developed, your architecture is which one? The prescriptive or descriptive?
Descriptive.
Descriptive.
Descriptive. Exactly. Exactly. Can they be the same?
Right. It can be.
The ideal way, yes.
In an ideal way, they can be same. Absolutely. Can they be different?
Yes.
Most probably they will be different, right? Okay. But at a given time, for example, we have not yet developed the system. So at that time, if someone comes and asks, show me your architecture, then you will show you the architecture. The architecture you will show will be called, more technically for us to understand, will be called prescriptive architecture, because this is something you're prescribing. This is something you're design, but it's not yet been implemented. While the system, the moment the system has been developed, you still have only one architecture, and that architecture, technically, you will classify them as descriptive architecture. And of course, in a very ideal world, they should be same. More realistically, they will never be same. They will have some differences for sure. Now, let's look at a very high level hypothetical example here, right? So this is something, I come up with as a prescriptive architecture. By the way, architectural diagrams are not very complicated, unlike the UML class and sequence diagrams. So usually we use blocks. So these kind of blocks are your components, okay? Components, and these ones typically are connectors. So let's say this is the one I developed, right? This is my prescriptive architecture style or architecture. I gave it to my developers, and now they have developed it. Which one is prescriptive and which one is descriptive in this case?
Left is prescriptive.
Yes, and the right one is your descriptive. System has been developed. Which architecture you will show it to your client or customer or whoever, or maybe some other technical team leader? The system has been developed. The right one, absolutely. Okay. Are they the same now?
No, it's not the same.
They are not the same. What is the difference, or what has been changed?
Interactions between them, I think. Change.
The interaction between the clock component and the vehicle.
Yeah,
or
so this has been changed, right? This was supposed to be there because you designer, as an architect designer, you said that this should be there. I, as an implementer, kindly change it on my own, right? So for sure, my prescriptive architecture is not the same as descriptive architecture in this system. Now, which one is correct? It's a hard question. Of course, we don't have the requirements here. We just need to make a call based on this information given in front of us. Which one is correct?
I think the right one, because they have developed the system and see the right one is more convenient than the left one.
Quite possible, absolutely. Somebody will like to share some other opinion, or everybody agrees that the descriptive one is the correct one.
Maybe they used the right one because they can't do the left one.
Yeah, maybe as a developer they realize that this connection is not possible, or technology is not supporting it, or something like this, right? Or it's not satisfying the requirements, right? Anybody else?
I think, Doctor, if the prescriptive one was correct and ideal, they don't have to change it.
Exactly. It's also possible. So it's the other side of the coin as well, as Muhammad said. If I designed this and I'm absolutely clear that I want this connection to be there because of certain reason, right? And if I as a developer go on and skip it, then, you know, if this is there for some reason, it needs to be preserved, then it needs to be preserved. Then this is incorrect, right?
Yes. So if they take it out, that means the perspective was wrong, or the this.
Or the descriptive is wrong, right?
Yeah.
Yeah. Or let's put this word. Let's use this word that they are not the same. So this means either this decision was, you know, it's required and absolutely must. Hence, the developers should go and fix it. Or if the developers are able to convince that, you know, this connection is not required for whatever reason, right? For some security reason or something like this, then you can take it out. But it's very important that because this has been developed, so either if you believe that this needs to be there, you go and update your code and actually implement it, and hence this line of connector will come back here, right? Or if you believe that this is not required, hence what you need to do now?
Nothing. Keep the descriptive as is.
Keep the descriptor as is. Should I go and update this?
No, I don't think.
But maybe you have to inform the architect and the designer that this change has been done.
Yeah, it's a good question. But as I said the other day, architect, you as an architect, because you are actually the lead. Actually, to be honest, you will be involved anyway. You will be monitoring this anyway, right? So, and of course, the developers has to tell them that, you know, we're not going to connect it if he doesn't pick. But should I go and update the prescriptive one now? Because okay, I agree. Khalas, I say okay, you convinced me. This connection should not be there. Should I go back and update my prescriptive one?
I don't think so.
So
I
what
don't
if
know.
I come tomorrow? What if I come tomorrow? I'll be and I come as a new team member and I need to understand the system, or maybe I need to evolve my system and improve it. I'm going to start with the documentation, isn't it?
Yes.
So I'm going to start somewhere here. And as per this definition, this diagram, I have a connection here. So maybe I built something on top of it, assuming that this connection is there, while in the source code it's not there. Are we calling for trouble here?
I think you should look for the latest architecture design. Since you will have one at a time, not two.
Yeah, so system has only one. This is true. This is my architecture, but this is developed. This is, as you know, so if it is documented and it has been, you know, drawn like this, khalas, that's it. I will not worry about this one at all. Okay. But if this is not drawn, this is still just a depiction of the source code. It is not drawn, then I should go back and update it. Update my documentation, like anything, because at the end of the day, next time I'm going to look at the documentation, because documentation is easy for me to realize the structure and the classes rather than understanding the source code, because source code understanding is a nightmare, isn't it?
Yes.
Right. And you know, more complex systems probably, you know, it will be very hard. So I think everybody understands this concept now. I think so, right? I have a feeling now.
Yeah, right.
Yes.
Inshallah.
Inshallah. So let's move. So basically, just take two concepts with you. Your system architectures change. Once the system has not yet been developed, we will call them prescriptive architecture. Once it has been developed, it will be called descriptive architecture. At a given time, you only have one architecture. Ideally, the descriptive ones should be in line with the prescriptive one. In other words, your source code should be in line with the model. Now, if it is not in line, then you need to check whether the code is correct or the way you designed is correct and code needs to improve. Whatever that decision is, make sure both are in line, both are synchronized. Okay, this is the point. Now, let's look at the definition of component. Remember, architecture, according to Mary Shaw's definition, is what? It's a collection of elements called components. These components interact with each other through connectors, and you structure your system using styles, and those styles impose certain constraints. So we'll look at what exactly is a component now. Component does what? It's an element that encapsulates the processing and the data of a system. Okay. And more formally is defined as component is something which encapsulates a subsystem of the system's functionality, subset of the system's functionality of the data. So in other words, information and data and functionality. It encapsulates it. It restricts access to its functionality or data only through interfaces, and they have explicitly defined dependencies or preconditions for them to be used. Okay. And a moment ago, we had a discussion that typically a class will not be classified as a component. It's going to be collection of classes, packages, more ideally collection of packages. Okay, so a component will be a collection of packages. Okay, within the packages, of course, you will have classes, right? So I have classes here as well, and they talk to each other, you know, through direct connections or whatever. And I have, you know, so this is component one. Similarly, I have another component which has classes in it, packages in it, and they don't talk to each other directly, but they talk to each other through these interfaces. Are you able to visualize this with me now?
Yes.
Now, how the encapsulation is, remember the encapsulation concept we learned for the classes, and we said that encapsulation at a class level is done through what? Public, private, protected, right?
Yes.
Here, the
For example.
components, we do that encapsulation. In other words, we are encapsulating the data and the functionality of one component from another component with the help of interfaces. So other components can only talk to this component through the interfaces. In other words, we are saying this is not allowed. We're not going to allow this. They need to talk to each other. They need each other's functionality. They need to go through the interface. And of course, when they will have some dependencies, like for example, this method, if you want to call this interface, you need to send the data in a certain format, right? So for example, it only accepts integer values or so and so forth. Everybody's comfortable with the concept of component here?
Yes.
Yes.
Alhamdulillah. So it's going to be packages. It's going to be collection of packages, okay? Last thing for today, and then we'll stop. Then I'll have one or two discussions for us. Components, and I'm using a word typical here. So components typically provide application-specific service. In other words, these components you write, they are written for requirements of an application most of the time. That's why I'm using the word typical. Of course, because it's not mathematics, it's not like discrete mathematics formula algorithms you prove, right? You can always come up with an example where these components are generic in nature. You can always do that. But typically, these components are there for a specific application. So components typically provide application-specific service. Okay? Because they are there for providing certain functionality to the system. And that's what it does. At the end of the day, a component actually does encapsulate functionalities of the system. Everybody's comfortable with this? Okay, alhamdulillah, I think so. So we're going to stop it here, guys. We have only 2 minutes to go. So we're going to stop it here. We'll talk about the connectors and other concepts, inshallah, next week. Let me stop the recording, take the attendance, and